All right, so welcome to this video on the topic of kinematics, motion in straight line, motion in one dimension. Very important numerical from NCERT, and therefore pay a lot of attention to this problem. Okay, let's see. It's a velocity time graph, right? This is velocity, this is time, and we have to analyze this velocity time graph to be, answering these questions. So let's start from there. Now, from this graph, look at this graph, V versus T graph. We have to look at this point and this point. And of course, then we have to look at the question. So let's start with A. The question is, which of the following formulas are correct? And how do we decide that? By understanding the graph. Understand the graph. Understanding the graph is very important. Understanding the graph. If you can understand the graph, you will be able to answer this. All right, let's look into the problem number A, right? This one. It says X position at instant T2. So this will have some position. This is Vt, but they're talking about position right now. So it's position X T1 plus V at instant T1. This is velocity at instant T1 multiply by the time elapsed, right? So this is T2 minus T1, time elapsed. T2 minus T1 plus half A T2 minus T1 whole square. Now, we need to decide whether this formula is correct or not. Whether this formula is correct or not. Let's look in, and how do we decide that? By reading the graph. If you read this graph, what it says is that the body has been displaced. The displacement is given by the final position minus the initial position is equal to the velocity at time t1. Whatever is the velocity here, right? This is vt1, vt1, and this is the velocity which is vt2, vt1 and delta t, which is t2 minus t1 plus half acceleration t2 minus t1 squared. Do you see there is a mistake in this particular formula? There is a mistake. If you look into this graph, the slope of this graph, okay, the slope of this graph, let me just use some different color to help you understand what I'm referring to. The slope of the graph, let's look at this point, right? If I draw a tangent to, the slope of the tangent to this curve here is this. If I draw a tangent here, the slope of the tangent to the curve, the slope is different. So at this point, the slope is different. At this point, the slope is different. The slope of tangent. So, and what is the slope of VT graph going to give you? Isn't this a VT graph? It's a V and T graph. Slope of a VT graph gives you acceleration. Acceleration, right? Now, if you look into this particular equation, the impression it gives you is that A acceleration is uniform, right? V is equal to U plus AT. This is, or you can say, S is equal to UT plus half AT square. V square minus U square is equal to 2AS. What is the condition in these equations? That this particular acceleration is uniform, it is constant, which means the VT graph should be a straight line, right? So the acceleration everywhere is same, but in our situation, the acceleration is variable. It is changing continuously. So we can clearly say that this graph, this formula is not correct. It is not correct because this formula tells you that the acceleration is uniform. But when we look into the graph, the acceleration is non-uniform. So why is it not correct? Because the graph shows acceleration to be non-uniform. The acceleration is changing, and therefore this graph, the formula you have derived from the graph is not correct. So this is a wrong graph, right? So we have answered one. I hope this made sense. Always ensure that when you see these types of equations, whether the acceleration is uniform, non-uniform, what is the story behind the formula, and try to link the formula with the graph. You should be able to read the graph very carefully. VT graph for a uniform acceleration, the line is straight, but in this case the line is a curved line, like it is going like this, and then it is going like this. This is not a uniform acceleration, but the equation is that of a uniform acceleration. Let's talk about V. V2t is equal to, let's say this is the final velocity at time instant. So I will just call it V2t is equal to Vt1 plus A T2 minus T1, right? This is quite similar to this particular situation. The final velocity, initial velocity, acceleration, acceleration, time elapsed, time elapsed. But again, this equation, V is equal to U plus AT, is applicable to what? For uniform acceleration. Uniform acceleration. Do you think that the acceleration for the given graph, which is this, is uniform? It is not. The graph is that of a non-uniform acceleration motion. Non-uniform acceleration motion. Okay. So how do you, so what's your answer? That this formula also is wrong because it has uniform acceleration, but the graph is non-uniform. This graph is not related to this equation. For this to be true, the graph should have been like this. The V versus T should be like a straight line because this is represented of a uniform acceleration. A has to be constant, but in the given situation, A is non-uniform. So even this is not a correct representation. Let's go to C. C is V average is equal to the final position minus the initial position divided by T2 minus T1. Let me, now from this graph, it is impossible to understand, what is the position because the graph is VT. Now, this VT graph is not given in terms of position and time, but we know the general definition of average, right? What is a general definition of average velocity? General definition of average velocity. It is the final position minus the initial position upon the final time minus the initial time. So this is delta t. This is a general definition of V average. The story behind V average is if you have a graph of X versus T, and maybe it is like this, okay? We have not been given X versus T, but I'm just telling you, if this is your point X1, okay, and this is your point X2, this is your point T1, this is your point T2, T1 and T2, then the average is represented by the line joining these two, subtract these two, which is x2 minus, so x2 minus x1. Average does not care about what is happening in the intermediate state. The average is only concerned with end states. This is end, right? End. This is the beginning, the initial point. So average is always concerned with the ending and beginning. If you look at this also is concerned with ending and beginning and ending and beginning time. So this is correct. This is a correct formula of the average velocity through the motion. Although the graph is V versus T, but we know the average can be calculated using this formula. So although the graph doesn't directly tell you, your general knowledge does tell you that. Let's go to the fourth part of it, right? So answer to C, yes, the formula is linked to the graph. It's a correct story. The formula is correct. The graph does tell you the average velocity is correct. D part, A average, right? A average. Now is A average is given to be the final velocity minus the initial velocity divided by T2 minus T1. Let's talk about the average velocity, the difference of the velocity. So we're referring to the same graph. Okay, let me redraw this for your benefit. Okay, it looks something like this, the graph given in the question. Let's say this is your T1. The velocity here is, VT1, and then the velocity here is T 2 VT2. What is the question? The average acceleration. What is average acceleration? It is also concerned with the final point and the initial point. So this is your final. This is initial. It doesn't care about what is happening in intermediate state. What is the intermediate state? Let me just draw the color of the intermediate state. This is the intermediate state. What is happening in intermediate state is none of the business of average. The average is only concerned with the last point and the beginning point. And if you see the formula, the last point and the beginning point. And therefore, even this is the correct formula. The graph and this formula link with each other. Remember the concept of average. Do not forget it. It's very tricky. This will help you. This logic will stay with you forever. You will never forget. Always listen to the videos with explanation. Don't waste time on solutions. You will learn nothing. This is the only channel which is telling solutions with great detail of explanation. Watch each of the videos very carefully. Let's go to the E part of it. E is again more tricky. Let me just change the color so that it's easy for you to read. Okay, let's talk about it. E. E, we may have to put some more effort because E is bit tricky. It's bit longish, but we will still decipher the code. Let's write the equation E. Okay, E talks about average. All right, so X to, sorry, X at position, at the final position, the initial position, and then it talks about the V average, the V average into the time, right? It is talking about S is equal to UT plus half AT square, V average into T2 minus T1. And then it is talking about, so this is your U multiplied by T. Don't get confused. We will discuss this just to make you comfortable. Half A average into T2 minus T1 square, right? So this is something like plus half AT square. S is equal to UT plus half AT square, right? This looks very attractive. Let's analyze this. Now, if I were to write V average, let me just do it algebraically. I will give you more explanations. This is X final position. Then this is the initial positions plus X2 minus X1 divided by T2. We know the definition of average, right? So I'm just writing that. T2 minus T1 plus half A average V2 minus V1 upon T2 minus T1 into T2 minus T1 whole square. So this got cancelled. So X T2 is equal to X T1 plus X T2. I have written X T2 as equal to X2, one and the same thing, minus X T1 plus half, this gets cancelled, V T2 minus V T1 into T2 minus T1, right? And so this gets cancelled. This also gets cancelled. What are you left with? You're left with 0 is equal to half. VT2 minus VT1 into T2 minus T1 is equal to 0. So V2 T2, sorry, VT2, either VT2 minus VT1 is equal to 0 or T1 is equal to T2. Multiplication, right? Either this is 0 or this is 0. So the answers you get from this is VT2 is equal to VT1. The other answer you get is T1 is equal to T2, right? This is all absurd. This graph doesn't tell you any of this. It's a very strange thing. So this equation is also not correct. Let me give you another example. If you were to find the total displacement which is happening, you can calculate it with the help of area under the curve, right? Area under the curve. Averages like these don't help you find displacement. What is the displacement? The displacement would have been x t2 minus x t1 is the displacement. And this is a non-uniform motion. The acceleration is a variable. So you should have used integral calculus. X2 x t2 minus x T1, which is the net displacement, is equal to V dt. This is the way you should have calculated it. Not this way. This is a wrong way to calculate the initial velocity to final velocity. The method used to calculate displacement is not based on averages. The final position and initial position don't decide. It is decided at instantaneous level. Everything matters in non-uniform motion. Every part of the graph is important, right? This area is important, this area is important, this area is important, this area is important. If you use averages, then only this and this is important, and you can see the consequence. Wrong answer. So always remember, if you have to calculate the displacement for a non-uniform motion, apply integration. I have numerous videos in my playlist. Go and watch calculus based numericals. Also, go and watch my series Maths for Physics. You will see a lot of questions based on integration. I have helped you explain what is integration, what is derivative. These are very important for this physics. Go and watch it. Let's talk about the last one. X2 minus xt is the area under the curve. This is what I told you, right? Let's talk about E and then F. I just gave you the answer of F, right? F talks about that the displacement is the area under the curve. That is the way you solve the displacement for non-uniform motion. Non-uniform motion means the acceleration is not constant. How do you calculate the displacement? The displacement is calculated by integral calculus, right? This is it. So this is the way you calculate delta x. So the F is a correct answer. I hope you enjoyed this video. Subscribe to my channel. Don't miss any of my solutions. You will score very well if you continue to follow my channel. This channel has 2000 explained videos, just not solutions. With the help of solutions, you will learn nothing. But with the help of explanation, you will learn a lot. The logic will stay with you in the examination. I hope you loved this video. If you do, put some comments, put some remarks. If you are facing difficulty in a question, write the question in the comment section. I will solve it for you. Thank you very much for your time, and don't forget to subscribe to this channel because this is the only channel giving you what? Explanation. Thank you.